Good morning and welcome to the second installment of the Southern States Energy Board's winter webinar series. I'm Turney Foshi, the Communications and Design Specialist for SSEB. This webinar serves as an accompaniment to our previous video available on our website, where we discussed the surge in electric vehicle sales and related electrification transportation infrastructure initiatives. Today, we're going to expand on that topic further by exploring the power source behind electric vehicles and much more, the battery. In our last webinar, Stan Cross from the Southern Alliance for Clean Energy noted that EV sales rose significantly in the third and fourth quarters of 2020, despite record-setting unemployment and unprecedented travel restrictions. And the demand for battery technology doesn't end with EVs. According to a March 4th report from E&E News, the battery storage sector has grown exponentially in recent months. In the last quarter of 2020, nearly 2.2 gigawatt hours of energy storage systems were put into operation. That's an increase of 182% from the previous quarter, which had smashed records as well. And after the devastating ice storms in Texas, perhaps predictably, market analysts reported a surge in home battery sales. These demands drive industry to expand and innovate. Battery manufacturers are responding to the demand for more batteries, and battery engineers are addressing the need for better batteries. During her confirmation hearing, the newly installed Energy Secretary, Jennifer Granholm, stated the choice we face succinctly. She said, "We can buy electric car batteries made from Asia, or we can make them in America." So, over the next hour, we're going to reckon with that demand for battery technology, its role in transportation electrification, and its potential to help meet the nation's energy demands and decarbonization goals. Our first speaker today is Stephen Boyd with the U.S. Department of Energy's Office of Energy Efficiency and Renewable Energy. Stephen is here to discuss the ways in which the federal government can help drive innovation. We also have Georgia Public Service Commissioner Tim Echols joining us today, and he will discuss the state's role in encouraging battery development and production. And last, we'll have Matthew Renna. He's the Vice President of E-Mobility and Innovation for Volkswagen Group of America. He's here to discuss VW's response to the demands of transportation electrification as well. After today's presentations, we'll have a short Q&A, so please leave your questions in the chat for our guests. Before I introduce our first guest today, I'd like to announce that SSEB will be hosting its 61st annual meeting in person in Oklahoma later this fall. Our chair and governor of the state of Oklahoma, Kevin Stitt, will lead our three-day conference as we explore the new energy frontier in America. Please subscribe to our newsletter for updates concerning our annual meeting and all other future events, both virtual and in person. Now I'd like to introduce our first speaker today, Stephen Boyd. Stephen is the Batteries and Electrification Program Manager in the Vehicle Technologies Office at DOE. He graduated from a university that we frequently collaborate with at SSEB, and that's Virginia Tech. It's there that he attained a master's in mechanical engineering and began his work at DOE in the Vehicle Technologies Office in 2006 as a technology manager for hybrid and electric systems. Stephen, thank you for joining us today. You're going to talk to us about your office's current work with regard to battery technology and transportation electrification initiatives and investments. I'm going to go ahead and spotlight your video, and you should be able to start.
Thank you, and thanks for that introduction as well. I'm going to go ahead and share my screen and get those up for you all. As you mentioned, I'm the program manager for batteries and electrification R&D at the Department of Energy in our Vehicle Technologies Office. This is a short deck. I'm going to try to keep to my time limit on just an overview really of all the activities that we sponsor as our part of the program and from the Vehicle Technologies Office. And so I'm mostly going to talk about batteries to fit into the topic today, but I want to just start by touching on a few different areas for our program that are of importance, starting with batteries and really focused on cost reduction of batteries as our first goal there, ultimately getting to, or batteries that we think can ultimately get to $80 per kilowatt hour, including a fast charge time, something like 15 minutes or less. The second goal there, looking at vehicle and grid integration, charging of electric vehicles on the grid. And, we really have the same goal there of enabling fast charging from the grid and mitigating any grid impacts from charging multiple electric vehicles. And then finally, the last bullet there, we're working on electric drive systems, and our 2025 goal is to get to a 3-liter high power density traction drive system at a cost of $6 per kilowatt. So let me start by going into just a couple headlines here in terms of batteries and what we see in terms of a few headlines and trends from the market. On the left there is a trend from Bloomberg NEF. And I use this graph because I just want to point out that, sort of on the left there at the thin part, we have a lot of demand from consumer electronics for batteries, primarily lithium batteries in this graph. And if you just sort of look and project out, that blue bar gets really large. That's passenger EVs, light duty vehicles. And so that's where most of our focus is in terms of research focus and in terms of where we see the market going. And even on top of that blue line, if you look out, commercial EVs is kind of second there. And then and in addition to that, e-buses. So these are all vehicle uses of batteries, projecting to be the majority of demand. And then you have consumer electronics and stationary storage as a bit on top of that. And so we sort of agree with that outlook. We think vehicle batteries are going to be a very dominant force in terms of the market demand. And then on the right here, this is sort of one example outside of our work where they're projecting cost reduction in terms of batteries. Again, we think ultimately we can get that down to less than $100 per kilowatt hour. We're targeting something like 80. And just a couple of headlines on the bottom there. In particular, I'll point to the last one, which is major EV growth in the past few years in Europe now, actually superseding China in terms of the growth rate. And so again, just pointing that we see this trend definitely increasing in terms of battery sales and battery demand globally. This slide really starts to drill down into a lot of the focus area of our battery R&D, which is really focused on cost reduction. And when I say cost reduction for batteries, I actually sort of want to talk about 3 different chemistries. Think of these as 3 horses in the race, if you would, that we're following in terms of how we can get there. The first is that green line, and the green text that goes with it, which we would refer to as conventional lithium-ion technologies. We benchmark those currently as in 2020. We said that those have achieved a cost of $169 per usable kilowatt hour. So that's $143 in terms of a rated cell energy in 2020. And which is a large reduction since we started focusing on lithium-based chemistries in 2008, over 80%. And then back to that graph, the second curve that's sort of a bit steeper and coming in kind of around 2017, 2018 is also lithium-ion technology, but this is utilizing a silicon anode. And we think those chemistries can achieve even greater energy density, and in terms of per kilowatt hour, we think that cost can go lower. And that's one of the chemistries we think can get to this $80 in 2030 sort of metric that we're looking for. Even beyond that, the red sort of arrow there, lithium metal or solid lithium based chemistries we think can go even lower potentially than that $80 per kilowatt hour target, but they have significant barriers to overcome. This is really like basic science and significant material challenges left remaining. So we think that's also a promising chemistry, again, to get to this cost reduction, but significant barriers in the way there. On the right is just a couple examples of technologies and partnerships that we've used to commercialize technologies. I won't go into detail on those other than to say we have a number of projects that are focused on commercializing technologies, and we've shown success in doing that in the past. This slide goes into a little bit more detail in terms of these 3 different chemistries. So note the same colors there, on the left, sort of a conventional or enhanced lithium ion as green. Next generation lithium ion batteries using silicon anodes in the center in blue, and then on the right, long-term, high-risk sort of lithium metal-based chemistries. And I'll just note that you see the specific energy for each of those cells in terms of watt hours per kilogram increasing. These are notional numbers, but again, this is targeted on what we see from a cell research basis right now. And for each of these, you'll note some different gaps or different challenges we see for these batteries in those tables there. And so each sort of has their challenges to overcome, but we think these are all sort of in the race in terms of getting to the cost numbers and the sort of performance characteristics we need for vehicle batteries. I want to include a slide here on some recent activity that we've started. This is a bit broader than DOE. This is sort of a cross-government effort that we're leading, that we're calling the Federal Consortium for Advanced Batteries. This is with our office as the lead and 17 other federal agencies, where we've established this group that's really focused on both lithium battery technology, but even broader than that, really the battery materials and the supply chain that's going to serve both commercial and military applications. And so, as it says there, we sort of have a technology focus in the cells, which is really our background, but then we want to fold in some of these additional layers in terms of market and supply chain, working with our federal partners across the government. And so right now we are drafting a national battery strategy that's going to take input from all these different agencies and look at all the different ways that we as the government can try to support what you see there as, a kind of a graphic understanding of the supply chain for batteries that can get to vehicles, including raw materials and materials processing, which we don't see a lot of right now in the US. To the cell manufacturing and pack manufacturing, which is sort of being established as we speak right now, in order to provide for some of the vehicles, the electric vehicles that are coming on the horizon here. Also add a slide here for another major initiative that we've started at DOE over the past year. Again, this is a bit broader than our office. This is sort of across DOE initiative for the Energy Storage Grand Challenge. This is, as I mentioned, a bit broader than vehicles. And so I apologize for all the text there, but I think some important details here where we're really seeing energy storage kind of apply across many of the clean energy technologies that EERE focuses on. And so that includes things like stationary storage. And we really see a lot of our work at the electrochemical level, at the battery cell R&D level, sort of as being complementary to a lot of the other technologies that we want to focus on, including energy storage integration into distributed energy resources or renewables like solar and wind. I have a couple slides here that are a bit broader than batteries that I'll just focus on in terms of our broad efforts for vehicles. And this is including 3 areas for what we would call vehicle electrification. And so this is the coupling of vehicles and to the grid and charging them from existing infrastructure. And so we see challenges and research opportunities in terms of extreme fast charging. This is high power charging a vehicle as fast as you can fill it from a gas pump sort of charging. So 400 kilowatts maybe and up for medium and heavy duty vehicles. Cyber physical security of charging infrastructure. So connecting a vehicle to the grid. We see that there are some challenges that can be addressed there. And smart charging, load management of vehicle charging on the grid. I also just want to point out a recent announcement just yesterday from our office. We've posted 2 notices of intent. These are a notice that we're planning to announce a funding opportunity for a number of different technical areas. And so I'm just highlighted a bit of what's in those documents here. You can easily Google search for those if you say search for EERE VTO or VTO funding opportunity or something like that. But these documents are out there now, and I encourage folks to look for those. There's some important topics we see going forward in terms of our work. Okay, and that's everything I had for you all today. Thank you very much, and I understand there'll be questions later.
So yeah, now we're going to go to Tim, actually. Let me do a quick introduction for you today, Tim. Let's see. Tim was first elected to the Georgia Public Service Commission in 2010. More than a decade ago, Tim founded the Alternative Fuel Vehicle Roadshow, which eventually grew into the Clean Energy Roadshow, an event that travels from city to city, helping businesses and municipalities evaluate alternative fuel sources for their transportation and residential use. And Tim doesn't just talk when it comes to pushing innovation forward, he embraces it. Over the years, he has owned a natural gas car, a propane van, and now an electric car. So let's listen to what Tim has to say today about encouraging battery innovation in the state of Georgia. Go ahead, Tim.
Hey, everybody. Thanks for tuning in. I'm actually on my 5th electric vehicle. So I started out early. I'm holding in my hand a AA battery. And these AA batteries are standard around the world. And there's lots of different batteries that are made out there, but this is where I hope we eventually get with automobiles, where things are standardized. And Stephen Boyd mentioned from the DOE about having a national battery strategy. And there's just been a lot of variations of standards, whether it's a Japanese charger standard or a German charger standard, and it's made it difficult, really, to move forward. And I understand that's just part of launching technologies as you're trying to find the thing that works best. My EV journey began in Israel, and the slide that I'm showing here is actually in Israel at the Better Place testing facility. That's Congressman Kwanzaa Hall there on the left, the African-American congressman who took John Lewis's place after John Lewis's death. But that's a Mitsubishi chassis with a replaceable battery. So when Better Place launched the concept, they thought, okay, the way EVs are going to work, this is way back in 2011, before Nissan Leafs ever hit the US market. Hey, we'll just pull into a battery replacement Jiffy Lube like facility, take the battery out in 2 minutes, put a new battery in, and you just buy a car with no battery and then pick your battery plan. And that was initially how they thought it might work. That didn't work out so well. They tried this in the Bay Area and then went bankrupt. This is Lisa Cupid, the Cobb County chairwoman. I'm sitting there with her, showing her how the charge point chargers, that's a level 2 charger at Six Flags, and you can see the roller coaster in the background. That's just off I-20, and we have really pushed the power company to build out chargers, and they didn't need much of a push because, hey, people are buying their electricity, right? I mean, it only makes sense. That's my wife and her first EV, the 2013 Nissan Leaf. We had a fantastic experience with that. I often tell families, look, if you have more than one car, one of them ought to be an EV. Don't worry about having the range to drive to California. Use your other car for that. Use this car for your commuting. My wife taught school, 12 miles there, 12 miles back. The cars, you could actually probably done that in a golf cart. But this car, of course, the Nissan Leaf, just a phenomenal car. We've got a Volkswagen speaker coming on, and they're making great cars as well. I had a Kia Soul EV. I'm plugged up there at a Kia dealership there. You can see the Nissan dealership in the background. I had a great experience with this Kia Soul. This was a 2015. Here's a Range Rover. This is the Consul General from the UK, Andrew Staunton, and the Brits sent this car over for him. He uses this in Atlanta. It's a plug-in hybrid. Not many of those out there. He got one of the first ones in the US. This is a zero emissions plug-in school bus, fully electric, made up in North Carolina by Thomas Built Bus. The Georgia company Bluebird also has electric buses. Thomas Built uses a fast charger on theirs, and Bluebird uses a level 2 charger. So kind of a difference. And folks that are in the market for a bus kind of need to think about that. I know Maryland has just put in a big order for these. This is these Georgia Power chargers that I mentioned, and they're everywhere. We gave them 8 million last year, 8 million this year, 8 million next year in make ready money. So that means they can go in, they can help a company that maybe needs some wires and transformers moved around. It's pretty expensive to move all that stuff around, and can have a little bit of a chilling effect when the utility tells the company, yeah, your chargers are 3,000, but we need 50 grand for the wires and transformers. And so we didn't want there to be a chilling effect, and my colleagues supported my motion in the rate case to be able to do this. I helped organize the world record Tesla parade. If you notice that highway has been shut down to all traffic. We did this in December on a Saturday, 380 Teslas in a line there, setting the Guinness Book of World Records. So it was a really, really fun event to raise awareness and fight human trafficking as well. We had the Rivian recently at the state capitol. This is me with the Rivian, kind of giving a walk around for the media. Trucks are important, especially when you're trying to convince rural Georgia that EVs are a thing. So you got to have a truck, got to have something, because they're going to have F-150s down in South Georgia, and you're not going to, be carting around on the farm in a Nissan Leaf. So Rivian making great progress. Battery prices continue to drop. I think you're going to continue to see, a drop, through the mid 2020s. So that's good. It's going to lower the cost of cars. The evolution of the battery, the Prius, many of you maybe had that early Prius. I've had 2 Priuses, and I've had 2 RAV4 hybrids that had the Prius powertrain. My wife loves that car. I'm in a Chevy Volt now. I've had 2 Nissan Leafs. Nothing wrong with any of this technology. I know sometimes we shame people that they don't maybe have the pure electric or something like that. We ought not to be doing that, canceling folks out for driving a Prius or something. I mean, it's a good thing, right? The Prius taught me a lot about driving a car with a battery. So Toyota really led the way, in the early 2000s, and in helping people understand that this could work. Battery prices are tumbling. This is courtesy of Cox Automotive. They own all the Manheim auctions. They have a great economist over there, Jonathan Smoke, who did this slide for me. You can just see, how prices are coming down. Looks a lot like that solar curve, doesn't it? As solar dropped in prices, so we're going to continue to see these come down. A lot of extra benefits, and this is, don't be afraid to tell Republicans like me about these extra benefits. That charging at home overnight provides better grid utilization and puts downward pressure on rates. It uses an in-state fuel. The vehicles weigh less than traditional vehicles, so they put less impact on the highway. And then, every 1% of petroleum-based miles traveled in Georgia that's displaced by electric vehicle has about a $201 million impact. So Republicans, we like economics, and there's no need to go to your Republican legislator and talk about climate change or global warming. Just forget about that argument. Let's just go with the economic, and we need more folks on board. We need Republicans to buy in to this, and we've got to give them these economic arguments, which aren't faux. They're real. They're real. I mean, charging at home overnight lowers rates. I mean, instead of, I tell my Republican friends, look, instead of mocking the guy driving the Nissan Leaf over there, you ought to give him a hug and a kiss, because if he's charging that thing at night, he's really lowering your power bills. We're doing some standalone batteries coming up here as I wrap up. 80 megawatts. A lot of it probably will go at a military base to help them be a little more resilient. Also put into our IRP a Second Life EV project. It's going to go down at Cox Automotive's pivot facility, basically take a bunch of Nissan Leaf batteries, put them in a container. These are used ones, gang them together with a battery management system, and let's see if we can get the rest of the life out of them. We're spending about $250,000 on that. EVs, growing slowly. I really don't think we're going to see it disruptive as quick as we think. Can see the Tesla Model 3 obviously dominating, Tesla Model Y, then X. So the German cars down toward the bottom, not having as much adoption. Of course, they're expensive. So we'll hear from VW in just a moment. You can see the EV volume change by state. California is the epicenter for EVs in the world, over 600,000 there. We are forecasted to grow. I think we are going to continue to see that. I think the Biden administration is going to provide some additional incentives. Finally, the barriers that we need to always address. The battery, which we're talking about today, 83% of EV folks that are interested in EVs are concerned about that battery, and then 70% about the cost. So see more on the Cox Automotive study. Happy to send that to you if you're interested. And there's Jonathan Smoke's email address, jonathansmoke.smoke@Cox Auto Inc., and he can tell you more. They know more about cars probably than anybody on the planet. They own more car auctions than anyone. So with that, Turner, thank you so much.
Give me just 1 second here to bring my screen back up. All right, that was great. It's really interesting about the 83% are concerned about the battery. I mean, it's definitely forefront on consumers' minds. So thank you, Tanner. We're going to move right along to our final presenter today, and that's Matthew Renna. Matthew Renna is the VP of E-Mobility and Innovation at Volkswagen Group of America, a role that encompasses product, production, financial, and sales objectives for all Volkswagen electric vehicles in North America. Prior to joining VW, Matthew ventured into the fledgling electric vehicle industry at Tesla in 2012 as an engineer, and he continued to grow in operations and management roles until finally leading the Model S and X programs. Thank you for joining us today, Matthew. I'm going to spotlight your screen now. Just 1 second. Are you there, Matt?
All right.
There you are.
Yeah, I'm here. Can you guys see me and hear me?
We sure can.
Good.
Go ahead.
Good. Well, thanks for having me. As mentioned, I'm a longtime EV supporter and evangelist, as we call ourselves. Tim, I think I'm actually tied with you in number of EVs I've had, which isn't surprising. I've had about 5 in total. And just to contradict your one point, we are actually 100% EV house. Not saying that I'm better than anybody, but it is possible. And we don't have any range anxiety anymore after being in the business for a long time. And, driving my cars down to 2 miles of range many times and not worrying much about where my next charge is coming from. I think experience with EVs is absolutely what gets people talking about them and gets them comfortable with the difference in powertrain. As was mentioned, at Volkswagen now and focused a lot on our electric vehicle launches. I think as a lot of people are aware, we've just put out our ID4, our first compact electric SUV that aims to address the mass market. And it's a really important product for us. It's a really important product, I think, for the EV industry and for battery electrification. We are doing our part. We're spending a lot of money promoting this vehicle. Cross-country drives, Super Bowl ads, a lot of marketing buzz, social media, all of the above. And then on the product side, we're doing everything we can to optimize efficiency, range, and cost. And it's a tough balance. I think there was a UBS report that was published just this past week that showed the technology in the ID3, which is kind of the sister car to the ID4, the smaller form factor European-only car. That demonstrates that we've nailed a lot of these, key features, key criteria when it comes to range efficiency and battery technology. So we're proud about the ID4. We are selling it in all 50 states, which is important for us. It's not a California product. It's not a ZEV state product, but we really see this being mass market product because I think everybody wants EVs at this point, and we don't want to limit that based on government incentives or CO2 credits on the back end. It's really important for us to democratize electric vehicles. In terms of our investments, we're making some big ones here. The largest of which being, at least for us in the U.S., the largest is in Chattanooga, where we'll be producing the ID4 in 2022. It's an $800 million facility. It's LEEDs Platinum. It's already a clean facility, and beyond this, our suppliers are investing substantially. We have our battery manufacturer in Georgia. Of course, there are some legal obstacles and things going on right now, but hope this is resolved soon, because we're looking forward to having a domestic partner for battery production that's able to produce high efficiency, low cost cells to keep our ID4s on the road. And these Georgia batteries serve our Chattanooga production, as well as some other OEMs that we know of in the area. And as far as the infrastructure, I have to mention our colleagues over at Electrify America. And we're jointly, as Volkswagen Group, investing heavily in the infrastructure and fast charge, in home charging, and basically, electrifying the road and doing all of this in order to promote electric vehicles, but also make a better user experience. We're focused heavily and have things in the future coming to ease payments and ease transactions. So really reduces the range anxiety and a lot of the fears that people have switching to electric. And obviously it's new for people. It was new for Tim and myself years ago when we first jumped in. But as you can hear us talking about these things, some people wonder why we're so excited. And I think the experience really is better. The cost of ownership. You don't have to put gas in the fuel tank. You're able to charge at home, charge at work, charge on solar. It's clean energy. It's fun to drive, and I'm excited about it. Volkswagen's excited about it, and I hope all of you are too.
Yeah, we certainly are, Matt. All right, do you want to move on to questions today? Is everybody ready?
Yeah.
All right, let me go ahead and we can just have everyone's video up now. So first question today is actually one we got from registration. Let's go ahead and hop to it. It's actually directed at you, Matt, if you can take a stab at this. I alluded to in my introductory remarks that the demand for EVs, despite everything this past year, has risen. And I want to know, Matt, has that surprised you? Was VW anticipating this surge? And by association, the surge for battery components?
Mm-hmm. Yeah, so I think maybe not many people know this, but VW actually got our start in electric vehicle development back in the 70s. And I learned this, I saw some pictures of skunk work projects back then using lead acid batteries to power Volkswagen buses. Obviously, these weren't commercial vehicles, but I think the technology aspect has been fascinating to us for a lot of reasons. And that technology, although in low volume, prototype vehicles or even pilot fleets of 50 to 100 cars, they've persisted throughout the decades. And leading into 2014, when the e-Golf was launched, and also the e-Up in Europe, I think there was general recognition, broad recognition that electric vehicles would be the future. And so our investment in the MEB platform happened around that time. Our first fully dedicated battery electric platform, long range, low cost, couldn't be converted into an internal combustion car, started in 2015. So I think we were a few years ahead of the curve here. There's been a ton of excitement maybe these last 2 years as sales have spiked. Obviously, we know that prices have come down and these cars are more accessible. But I would say that our lead times for development, especially on new platforms, is particularly long. And you see us launching cars here in 2021, and even towards the tail end of last year, some cars in Europe on this new platform. I think we were ready for it. We have a dedicated platform in the Volkswagen brand. We have a dedicated platform in the premium brands as well, coming as through the e-tron and the Taycan. So a lot of BEV products, and I think our future is bright.
Okay, a related question to that actually is, we know that the pandemic has bottlenecked supply chains across the planet. And we had a question wondering if you could talk about the ways that the pandemic has altered VW's plans, if it has at all, and how you've adapted throughout the pandemic.
We haven't changed our plans based on supply issues brought through in the pandemic. I think the topic of discussion that has a lot of us focused is the semiconductor shortage. I think that's industry-wide and powertrain agnostic. We are certainly engaged with our suppliers and their tier 2s and tier 3s in order to kind of alleviate those shortages and do whatever we can in development to be as flexible as possible. But again, I don't think that affects EVs particularly more than ICEs, but it's definitely something that we spend a lot of time and focus on. But the short answer is no, we haven't changed our plans based on that.
Nice. Okay. Let's see. This next question, I think maybe you could provide a little bit of an answer here, Stephen, and maybe you as well, Matt. But what are the unique infrastructure needs of EV battery production and its component suppliers? So I'm guessing we're talking all the way down the chain there.
Sure. Yeah, it's a pretty big question. And when you say infrastructure needs, I don't know if that's referring to, who knows that. I often think of infrastructure as like charging infrastructure for vehicles.
I imagine they mean charging infrastructure being ready once the batteries are coming online.
In terms of, so that in terms of battery suppliers, I don't know if there's a good link there. I mean, I think what I would say is that we're really pretty deep into analyzing supply chain for batteries to provide for automotive needs, and I think that's so this is a future outlook, right? You have to do some projection, but I think we're actively working in that area, and as I mentioned, we pulled together a federal group to try to look at this and do some more analysis and figure out where we think we should be making our plays, which is obviously. Many other folks are making moves and, sort of putting infrastructure and investments in as well as we speak.
Did you have something to add, Tim?
Yeah, I'm just thinking about the SK Innovations plant and what was needed, to attract them to Georgia, right? So just up 85, within commuting districts for the Korean community that live in North Atlanta, in that Doraville, Chamblee, Brookhaven area. And that was important because it is a Korean company. Free land, essentially. It is a massive factory. And you'll see it when you drive up 85 or drive down 85 if you're coming to Atlanta. And then just some sweet terms from the state of Georgia and economic development. I mean, we've, and energy. Think about energy cost, right? And this plays into all of this as well. So, we work hard, every day in Georgia trying to get companies, to come to our state, and energy cost is a part of the mix.
Yeah, it's definitely something to keep in mind. I think somewhat related to what you were talking about, Tim, is the question we have about what is the biggest roadblock to battery production right now? And all three of you may have a different answer there for what you believe the biggest roadblock that we face is. Who wants to take a stab at that?
I can jump in and give some of my thoughts. Of course, I don't represent a battery cell supplier. I'm here speaking on behalf of the OEM, and we have a view into the battery cell supply chain, but it's not the complete and ultimate view. But of course, I've been around the industry. I've seen some things, and I would say that battery production is a tough thing. It's a very complicated chemical handling and material handling, where you need to demonstrate very high quality with very exacting standards. And as from an OEM perspective, as we push the limits of performance and energy density and range density, we're getting to the point where manufacturability becomes more difficult, and we have to take on more advanced techniques and methods. And from a quality and plant perspective, you need to be stable in your process, and in order to drive high yield and low scrap rates. And so you can see, like, as the industry is really pushing to advance and pushing our suppliers, I think a lot of the challenge that we face on a day-to-day basis is how do we do that in a way that is economically viable and sustainable, and low scrap, high yield, just consistent manufacturing process, because obviously we want to deliver the best total product, and that has a number of different characteristics.
I'm hoping that the Biden administration will be able to get some standards done for the recycling of lithium ion. I know that it is a concern. And my concern is that maybe some states have it, some states don't, and that these companies are going to gravitate to the states that don't have it. And it doesn't really solve the problem. I mean, there is an issue surrounding the recycling of this material. And I think we owe it to ourselves to try to do this right. I mean, we have millions and millions and millions of solar panels in Georgia now, and we don't really have a recycling program for those when they get to the end of their life. So there is a chance that the aluminum will be pulled off of those and they'll be ground up and thrown into landfills. And that is not where we want to go. So I do think it's worth thinking about these issues now instead of waiting until we get to later.
I'll just chime in on two aspects there. And one, we've started a number of programs in terms of battery recycling, including we have an active battery recycling prize, which is a prize-based competition where we have a number of small businesses that are sort of competing for business models to enable a lot of the different aspects for battery recycling. So, that can be shipping, sorting, supply chain kind of stuff. We also have a battery R&D center that's looking at both battery design and electrochemistry for better recycling in the future. In addition to battery recycling processing methods, so how you can either be more efficient or more effective in terms of battery recycling or use less energy for recycling cells. I'll also note that a number of different folks involved in terms of secondary use of batteries. So after it's done in a vehicle, there's still some things you might be able to do with battery cells that were meant for vehicles even after the vehicle life, right? And the second point I'll make is we do see some gaps in terms of cobalt supply in the near term. And so a few years ago now, we started a number of different efforts, specifically targeting reducing the cobalt content of cells. And we've seen some success getting those down. The industry as a whole has sort of moved to a lower cobalt content cell overall. But we think there's opportunities to get that down to even 5%, maybe even 0%, sort of in the near term. We would see that as that sort of, if you remember my slides, the sort of next generation of lithium cells, not even to a silicon anode step.
Let's see, we got some other questions here. I think you kind of touched on this just now, Stephen, but we had a question in the chat asking how recyclable is lithium ion battery components. Do you want to speak a little bit more about what we can do with that?
Sure. I'll just add that, currently most of the recycling methods rely on like a pyrolysis. So literally, like a melting down the cell sort of approach. And we do think there are advantages to doing it in a hydrolysis method, so water-based, which is a lot less energy intensive. We're hopeful that recycling methods can progress to the point at which we can keep some of these constituent materials together. So perhaps cathode processing to keep cathode materials intact, and this would almost be like a cell refurbishment sort of process. In addition to, I mentioned some of the secondary use and other sort of business models around recycling battery cells that we're hopeful to see.
Okay. Let's see. We have one question here. It's for you, Tim, actually. See, they say they live in a rural area serviced by EMC. What can be done to inspire the EMC to embrace EVs and install charging stations?
Well, I know Oglethorpe Power, which represents all of our EMCs here in Georgia, kind of a conglomeration of EMCs. They've hired Alan Shedd, who, if I was on a desert island, I definitely want the guy with me. He can do any and everything. He's built cars and everything else. And so he's their EV guy. He works with all EMCs. And we even, Alan and I even went up to the Atlanta Motorsports Park, the big fast go-kart track that Bill Edwards, that Bill Elliott and his family on their land. And we invited all the EMC presidents up there for a go-kart race, and everybody that lost, that means from second on back to number 16, had to promise to buy an EV for their EMC. So, and then we raised some money for low-income ratepayers to provide, this was during the pandemic. So there are things that we can do. I think the EMCs are going to be behind the big utilities. There's just no there's no way they can get out ahead of them, but they can catch up. And what the EMCs can do is show the rural parts of the state that this works. And one of the things that our EMCs are doing by buying these cars, they loan them to the membership. So you can come in and check out this Tesla or this Nissan Leaf and drive it around for 3 days. And that gives you an idea of what it's like. And to me, that's real leadership.
Definitely. Let's follow up for you, Tim. We had a question. This is really related. What can state legislators do to further incentivize EV adoption and to accelerate battery innovation?
You know, I think we're the only state that had a tax credit in place before, you know, the Nissan Leaf got here. So this was actually was inspired by the Prius, and some Republican legislators had done this. It wasn't in the modern day era of EVs, but the credit was in place. You could take it in 2 years. So it was an additional $5,000 over and above the $7,500 tax credit. And what we saw is that first the Indian community figured this out. They figured out, wait a second, I take this in 2 years, I can get a free car. So the Indian community in Lilburn figured it out. Everybody else followed. And we were the #1 market in the US for the Nissan Leaf as a result of this. And then once a couple of my Republican legislators were told we're getting free cars, they said, no, nobody should get free cars. And they eliminated that. And here's the experience that we have. We saw a 90% drop in purchase of EVs in Georgia. So I think that what that shows us is that tax credit, and I took 3 of them myself with my EVs out of my 5, that tax credit gave risk takers, you know, pioneers, the assurance that, hey, I can go ahead and buy this inconvenient car and test it out without killing myself financially. And in my case, I leased all 3 of mine, gave them back. I'm glad I don't have them anymore. They only had a 90 mile range, a 70 mile range when I gave them back. So I think states can come up with either a tax credit or, like Boston does, taking it out of the idling fine money. I think they do a $2,500 credit. A number of states are doing things, but I think it's still important for states to do this in order to jumpstart the market. The market simply is not mature yet, and it still needs some help.
Did you have anything to add, Stephen or Matt? It's okay. We can go to our next question. We actually have one in the chat here. We've talked about this a little bit already, but maybe you can expand on it a little more. Can the panelists address the issue of supply chain vulnerabilities? So, you know, vulnerabilities towards battery production for North America. I don't know who wants to take that one.
I think, again, another pretty big question. I guess I would just say that it's something we're really focused on in terms of trying to do what we can from the government side to support that. I think, as we've sort of talked here, it's a bit at a nascent or emerging stage. Certainly, vehicles have been around for a little while, but I think the expected increase in EVs coming is significant, right? And so, what does that look like when you scale that up from a few 100,000 today to many more millions in the future, right? That's what we're really focused on. So I can't say I have an answer for that, other than we see that as very important, and certainly a key or a crucial area of focus, especially with our desire to keep a lot of manufacturing and processing and those sort of that supply chain. We would like to keep that domestic.
Let's see. We have another question in the chat here. Let's see. This is for Stephen as well. Any insight on the critical minerals from from lithium to nickel? As a mining engineer, we must express concerns in the supply chain without significant government support. That's from Michael Karmas.
Sure. I don't know if I caught the question there. I'm not.
Sorry, I'll repeat it.
That's okay.
Do you
Well,
have
no.
any,
so I heard what you said. I'm
yeah,
curious what the. But I'm
just
just I'm trying
insight,
to
I guess,
process it.
from
Yeah.
lithium to nickel? Yeah, I don't know batteries as much as you guys, so
Yeah, I guess I don't know if I have much to add in terms of mining. Again, we understand that these things are critical, right? And the mineral, the needs for these materials can grow significantly, right? So that's an area of focus. That's definitely an area of concern. That's something we're actively looking at, and not just us, right? Specifically, as I mentioned, we're working with a number of different federal agencies, including Department of Commerce and some of these folks to try to figure out how we can best address either those gaps or that future opportunity, right? Depending on how you see it.
right. We had a question earlier in the registration process. I mean, you may be able to speak a little bit on it, Matt, and you as well, Stephen. They asked, beyond the federal funding, just the, money flowing in for innovation and risk taking, what are some other strategic partnerships that the federal government is doing or can do to encourage battery innovation and, electrification of transportation?
Yeah, I can jump in and answer that. Obviously, we rely a lot on our technology suppliers, and we as an OEM don't develop all of our technology in-house. So I think, areas where the government can get invested in EV technology is always helpful to us. It brings more advanced technology to the table that jointly address the common goal of, more efficient, more energy dense, lower cost EVs. I would say that's one area. We particularly don't find ZEV mandates all that helpful. It has some strange effects on the industry. And so I'd shy away from that. And obviously putting, tax incentives or whatever incentives that we spoke of earlier is ideal, but it's really a bridging strategy until the cost of batteries and the cost of battery electric vehicles comes into price parity with internal combustion. So I think, to sum it up, we need to advance the technology of electric cars, work towards, again, this cost efficiency, energy efficiency, to close the gap with internal combustion. And I think that's that's the free market way. That's I think the most lasting way to solve this.
Yeah, thanks for that, Matt. And I'll just say, I don't feel like I could speak on the part of some of the other agencies who their roles are outside of or maybe a little bit different than the technology and innovation side, right? That's what we come at from DOE. That's really what we bring to the table, and so that's what I can directly address and talk about here today. But as I mentioned, I think there's a lot of attention on the issue and a lot of folks looking at what we can do here.
I think we've really just got one more question here, and this is for all of you. It's kind of a large question, but we'll try to take a stab at it. What role will batteries in transportation electrification play in what the Energy Secretary Jennifer Granholm calls our irreversible path toward decarbonization? In other words, how are we going to meet those goals through batteries and, EVs?
I'll kick it off that, I think based on what I presented here, right, we really see light duty vehicles and transportation as a major contributor for greenhouse gas emissions, right? I think that's relatively well documented and understood. In addition to that, I will say that our work isn't limited to light duty vehicles. We see a lot of the same technologies can apply well to medium and heavy duty vehicles, including trucks and buses. And so a lot of that work is continuing. We're sponsoring some work in those areas. And then in addition to that, our office has been working in a few other application areas, such as off-road vehicles and construction, which also contribute to greenhouse gas emissions, as well as we've done some joint sort of assessment and support work in terms of electrifying aviation, as well as other DOE offices like bioenergy and hydrogen fuel have a number of efforts on some of the other sort of complementary fronts in terms of reducing greenhouse gas emissions.
Do you guys have anything else to add, Tim or Matt?
Yeah, we have a wonderful thing going in the U.S. right now. We've got very low cost natural gas, and the Germans have consistently told me that, hey, this is why there's a resurgence of American manufacturing. It's because of that cheap gas. It's why BMW fires that i3 body over in Spartanburg and then sends it all the way back to Germany to put it together. I mean, they need that cheap thermal heat. And over there in Europe, well, the Russians pretty much have them, on the ropes whenever they want to have them on the ropes. So I hope that we don't go crazy here, Turner, in forgetting about the importance of a diverse grid. Texas showed us diversity matters when it comes to grid. And I know in Georgia, we're going to keep it diverse if we can, as long as we can. Yeah, let's add batteries. Yeah, let's add more solar, but let's make sure we've got that reliable base load to keep everybody safe and warm and cool, as we go forward.
Any thoughts from you, Matt, on our decarbonization goals and how we're going to get there with EVs?
Yeah, I think EVs play a huge part of that. And I think next to decarbonization, we have to talk about sustainability. I think sometimes they get lumped together, and from my perspective, incorrectly so. And I think when we think about the benefits of battery electric vehicles, from a technical perspective, we're able to recycle these materials, we're able to reuse them. And I think that within itself creates a stable ecosystem of energy storage. And the applications of this energy storage can be in vehicles, could be in heavy duty, light duty trucks, can be in homes, can be in storage grids, next to power plants. And then I think on the energy generation side, maybe to address the last comment, I think the diversity is important, but I think we have to look at sustainability too. Everything from solar to wind to geothermal, that is diverse and it is sustainable. And I can see a future where that'll be important, not only on the generation side, but also on the storage side, like batteries.
Okay. I think that exhausts all of our questions today. Unless anyone has any final thoughts they'd like to add, we can go ahead and wrap up. Do you guys want to throw anything else out there? Okay. Well, since we've exhausted...
Thanks a lot for having us.
Oh, yeah, no problem. Great to have you, Tim. Just let me wrap up here today. I just want to thank all of our attendees in the chat today. You were very, very talkative. I want to especially thank our presenters today, Stephen Boyd, Commissioner Tim Echols, and Matthew Renna. Really appreciate you guys coming on. Today's conversation was an enlightening peek under the hood of transport electrification and the boundless possibilities for battery innovation and integration with our nation's grid. Remember to subscribe to our newsletter for future live webinar and event announcements. We've got a lot more planned for this year. That's it. Good talk. See you next time.